So let's start with the open addressing. In open addressing method, when a key collides with another key, the collision is resolved by finding the next available location or table entry. Uh, so in linear probing, just take an example of we are looking for linear probing. First collision resolution technique in open addressing, that is linear probing. So what happens in linear probing? Suppose if you have an formula h of 0, where this is what your key. So how we are going to do? Key mod size, whatever size we have, and it will produce an index location. If this index location is already filled, if it is empty, this index location, whatever index location it generates, if it is empty, then we are going to fill that slot. But if this location is filled with already any other key, then what we are going to do? We are going to find h of 1, that is for same key. So here what we are going to do? We are going to add 1 in a key value. So in a key value, suppose if you have key value 10, so 10 plus 1, so that is 11 mod and whatever size we have. Okay, again this location is filled with the value, then we are going for h2, that is k is equal to k plus 2 mod m. So we are going to add 2 in a key value and then we took mod for it. So in this way we are going to find the address location where to store that element. So this is what linear probing. So let's take an example. Suppose if you have key k is equal to 7, 36, 18 and 62. So these 4 key values we want to store in a hash table. And suppose our hash table size m is equal to 11, means how many elements this hash table can hold? 11 elements. So first I'm going to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and this is 10. So how many elements this hash table can hold? 11 elements can store. So let's insert an element, that is 7. So key k is equal to what? 7. First element we are going to insert. So h of 0, 7 is equal to 7 mod 11. Size of m is what? 11. Okay, so it will produce index location 7 itself. Okay, so at index location 7 we are going to store the value 7. Now next key value is equal to what? 36. So h of 36 is equal to 36 mod 11. So what will it will generate? That 3. So at index location 3 what we are going to store? The element 36. Okay, so here comes your 36 at index location 3 and 7. These two values are these two index location is filled. Now let's take the another index value, that is 18. So index key value, so 18. So h of 0 is equal to 18. So 18 mod 11. So this will produce 18 mod 11. Okay, so it will produce 7 again. 18 mod 11 is equal to 7. So at index location 7 we are going to store an element 18, but at index location 7 we already have an element that is 7. So here collision occurs. So in linear probing, what we are going to do? We are going for calculate h1. So that is 8 for 18. So 18 plus 1 mod 11. So 18 plus 1, that is 19 mod 11. So it will produce an index location that is 8. So at index location 8 we are going to store this 18. Now let's go for another number, that is another key value, that is key value is equal to 62. So for h of 0, 62 is equal to 62 mod 11. H of 0 is equal to 62 mod 11. So again the collision occurs. Again the collision occurs. It produces index location 7. Index location 7 is already filled. So we are going to calculate h of 1, that is equal to 62. That's 62 plus 1 mod 11. So again it will produce 8. 62 plus 1, 63 mod 11, that is 8. So let's look at 8. So this location is already filled. So again we are going to calculate h for h2, that is 62, that is equal to 62 plus 2 mod 11, that is equal to 9. So index location 9 is empty. So at index location 9 we are going to store that element 62. So using linear probing, in this way we can avoid collision, or we can resolve collision problem. So this is what linear probing. This is what linear probing. For such operation we are going to do same thing. We are going to use same formula and same operation to find an element. Okay, so now let's look at the another technique. Quadratic probing. So what is that? The next technique is what? Quadratic probing. So basically in quadratic probing we are using the hash function like h of I for the key value k is equal to hash function for that k plus I square, I raised to 2. So whatever i's value we have, we are going to square it, and whatever result comes from this equation we are going to find modulus of that. So you can say mod size of table. So this is what I'm going to write it again. h of I of k is equal to, we are going to use any hash function, simple hash function, k plus I raised to 2 size of table. If h of 0 for value k is equal to, how we are going to write it, like hash function, hash for the key k plus I raised to 0. So 0 raised to 0 is sorry, I square. So what is the i's value here? 0. So 0 square, that is 0. And size of, modulus of size of table. Now if this already filled with any this slot is filled with any element, then we are going for h of 1 for k, where hash for k plus, what is this, h1. So 1 square modulus of size of table. Okay, if this slot is again filled, whatever location it generates that is already filled, then we are going for h of 2 for k, that is hash k plus, so 2 square, that is 4 modulus of size of table. So in this way, in quadratic probing, we are going for quadratic increment, we are going for quadratic increment and so on. If that location is already filled, then we are going for again. So let's take the same example, like where key value k is equal to 7, 36, 18 and 62. So 7, 36, 18 and 62. Again our table size is what? Our table size is same. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is what our table size means. M is equal to 11. So hash table size is what? 11. Okay. So let's insert an element 7 first. So here key is equal to 7. Put into the hash h of 0 for key value 7 is equal to 7 mod 11. So it will produce index location 7. So at index location 7, we are going to store the element 7. Now let's take the another key value, that key is equal to 36. So h of 0, 36. So 36 is equal to 36 mod 11, that is equal to 3. So index location 3 is empty, so we are going to put that 36 here, don't worry. Now suppose now next key value, that is key value is equal to 18. Key value is equal to 18. So h of 0 is equal to, for 18, so 36 mod 18 mod 11, that is equal to 18 mod 11. So this is equal to what? 7. So collision occur. Since at the address location 7 we already have an element that is 7, so here collision occur. Then we are going to use quadratic probing. In quadratic probing, for h1, 18 is equal to 18 plus 1 raised to 1, 1 raised to 1 mod 11. So 1 raised to 1, that is 1. So 19 mod 11. So it will produce an index location, that is 8. So at index location 8, we are going to store the element 18. Now let's take the another key, that is key is equal to h key is equal to, that is 62. So h of 0, 62 is equal to 62 mod 11. So it will produce index location 7 again. Okay. Now 7 is already filled with element 7, so index location 7 is already with element 7. Now for H1 62, so again write like this: 62 plus 1 raised to 1, or 1 into 1, that is equal to, sorry, mod 11, that is equal to 8, but 8 is again filled with an element 18. So let's go for next level. So that is H2 62 is equal to 62 plus 2 into 2, quadratic form, in the quadratic form, mod 11, so that is equal to 0, that is equal to 0, since 62, 2 into 2 4, 62 plus 4, that is 66, mod 11, so it will produce 0, 66 mod 11, so it will produce the index value 0. So at index value 0 we are going to store that 62. So this is what quadratic probing, this is what quadratic probing. In double hash technique we are going to hash the same value, same key value one more time, means same hash function we are going to apply the same value, means we are going to apply more than one time same hash function for the generated value. Okay, now we are going to see chaining. In chaining, what happen, we are simply adding link to that particular address location. We are going to simply adding link to that particular address location. So we are going to just see with example. Suppose if you have key value like 50, 700, 76, 85, 92, 73 and 101. So these are what our key values. Okay, again we are going to use same function like division function, that is 50 mod, sorry, key is equal to 50, so h of k key mod m, key mod m. So let's assume that here our table size is 7, so 0 1 2 3 4 5, sorry, 6. Okay, so our table size is what, 7. So how many elements this table can hold? 7 elements. So 50 mod h of 50 के लिए 50 mod m is what, 7, so it will produce 1 is equal to 1. So at index location 1 we are going to store an element 50, an element 50. Now let's take an example of 700. So 700 mod 7, so it will produce index location 0 is equal to 0. So at index location 0 700 will be put. Now let's take 76 as a key value. So 76 mod 7, so it will produce index location 6. So at index location 6 we are going to store that 76. There is no problem while we are storing this value. Now let's take h of k. K's value is 85. Now 85 mod 7, So it will produce 1. It will produce 1. But at index location we already have an element 50. So in chaining, what we are going to do, we are generating a link for the next element, and where we are going to put that element. So 85 will be put at the link location 80, link, new link, that is 85. Now let's take an example, that is 92. So 92 mod 7 is equal to again 1, again 1, but index location 1 is filled. So again what we are going to do, we are going to continue with new link, and where we are storing 92 only. So in this way, in chaining, we simply generate a link, and at that link we are going to put that value. We are going to put that value. So this is what chaining. So this is what chaining. Now the last one, bucket addressing. Another collision resolution technique. In this collision resolution technique, what we are going to do, we have an bucket associated with that address location. So this is 0, 1, 2, 3, 4, 5 and 6. So this is what bucket, and this is what your key values, original key values. So let's take same example. So at index location 1 we are going to store the value 50. So here comes your 50. Then at index location 0 we are going to store the value 700. So put that index location 700 at 0. Now for 76 at index location 6 we are going to store 76. Okay. Now for 85 it will generate an index location 1, but index location 1 is already filled with the element 50. So in bucket addressing we are going to use bucket to store the next element. So in this bucket we are going to store the 85. Now next element is 92. 92 mod 7, it will ask for same index location, that is 1. Index location 1 is filled with 50. Bucket is also filled with 85. In this situation we are going to use linear probing, or you can say open addressing. So as per open addressing, next available location is what? Index 2. So at index 2 we are going to store 92. So this is what bucket addressing technique. So in this way we covered all the collision resolution technique which may be asked in your theory examination. So thank you very much. Thanks for watching.